There you go.
Okay, Jim. We got Jim Richards online, and he's got several things to talk to us about today, and then we'll see him again tomorrow. Take it away, Jim.
Okay, well, thank you all. Sorry I couldn't be with you in person. So for those who are new, I assume we've got some new owners or people here in the audience who don't know me. So I've been exclusively, my wife Martine and I, and my number one right-hand man partner, Tyler, have been, well, I go back and Martine goes back to 2005. We began first exclusively supporting the Commander fleet. That's all we've done for next year. It'll be 25 years. So it's 100,000 hours or way more of being inside, outside, all around, upside down, inside out, 7 things at the same time, all Commander all the time. And my role is as an engineer, MIT trained, mechanic, FAA mechanic, DER for the past 6 years now, so designated engineering rep for the FAA as we get into more ticklish requirements across the fleet with aging airplanes, and test pilot. I'm probably, hopefully, the only one of us who has done a flight at VD, which is 207 knots indicated, pretty fast. So we operate in all lanes, technical support, which we continue to offer free of charge. It does take a lot away from revenuable minutes and so forth, but we're still on that policy of I don't charge when you call and ask for help. With PMA parts that we offer, STC, airplane modifications, all of the DER approved repairs, there are hundreds of those things we've had to analyze and dig in, come up with appropriate repair strategies and so forth. Standard parts, the ones that you guys call for all the time, you guys and gals and everyone out there, this stuff we know you always need, and so we try to keep that stuff on hand. And inspections, regular annual inspections or special inspections, like coming in to have the gear looked at. We get some fair number of requests for that. And then what I call type inspection, which is inspecting your Commander for all of the conditions that we have seen occur over the fleet in that 24 years. So that's I call a type inspection, because it's, it goes way beyond whether or not you have wings, right? It goes into the things that that have been becoming issues on Commanders. So Don, if you could advance to that Friday 1.
I messed it all up now. Just hold on.
So first is just a quickie little blurb about a product we began offering just this past year. Okay. We're missing some of that screen. I don't know if you can take it up to any bigger.
You need to hit F11 again.
Yeah, I did. Is it not?
Yep. Looks good.
All right. Well, it's not all up, but we'll go with what's there. So this is a replacement guts kit for the brake pedal cylinder, the Gerdes A110-36 or the Gerdes W110-36. This does not service Bob Welch cylinders that came along in later years, even though they have the same part number. This services the Gerdes cylinders, which are junk like all Gerdes products, and they are beginning to go out across the fleet and become impossible to bleed, or maybe cases where the co-pilot brake cylinders, pedal cylinders work great, but the pilot cylinders and pedals don't really break as well as they should. So the advantages here in servicing a cylinder with this kit would be that these are new parts. Wowee, right? They're not old stuff that you're getting from salvage and transferring one broken part to another place. And so these are all brand new parts. And as we always do, we tried to look at the things that we thought were trouble with the original design, which were bleeding. There really was no design feature in these cylinders to be able to bleed them, to be able to push from the bottom, as you should when you're bleeding commander brakes, push from the bottom and have the fluid be able to get up through the co-pilot cylinders to get to the master cylinders to fill those as well. So there was no provision in the Gerdy's design for them to be bled. You could kind of do it most of the time. And so that's where we all were. So we specifically built into this set the ability to bleed and design features that are there for bleeding, if you know what I mean. And then improved master channeling down from the top. This is the issue where you may have good co-pilot cylinders, but your pilot cylinders really don't work as well. And that can be because when you push on the pilot cylinder, the fluid has to travel down through the co-pilot cylinder to get anywhere, right down, and then down through the parking brake and down to the wheels. And if it can't get through the co-pilot side on the way to the wheels, then your pilot brakes are not very good. So there's a specific design feature again in these which improves that channeling, so that when it's the pilot pushing his pedals, there's a good solid way for the fluid to get through and get through the co-pilot side and down and do its job. So I've got these on this. Don, can you put up the other screen? Do you see where I'm holding some parts? I think it's Jim's iPhone 13.
Hold on a second.
Yeah.
There you go.
Yeah. That's it. Okay, so in that screen over on the side, I've got a Gerdy's A110 36 cylinder. Most of these are fine. Your cylinder is usually not the problem, the body itself. So you would have taken some things out, like this spring would have come out of there. And there's a stop there's never anything wrong with the stop, and it's going to get reused. And the gland that goes in up at the top is usually not in any trouble. Needs a new O-ring maybe. So anyway, we would just drop that in there. And whoops, sorry, not quite yet. We'd put the thrust washer on here. We'd drop the new stop that we provide in there. We'd put this together, slide that down in there, and then the upper stop and the gland, put the snap ring in, and you'd be done. So it's a mechanic's dream because all the difficult stuff that you had to do before to try to service one of these, you don't have to do. You just do what I just did. And you do not have to take the pedal cylinder out of the airplane to do it. You just need to put a pan under to catch your mess, and usually you can succeed and do it right there. So that was a quick blurb on one of the new things from us this year. And we could take a couple of questions if there are any at this point.
Jim, anything for the old, gosh, I think it's A110 or something like that. The older 112s used the master mounted right to the pedal. Anything for that?
Yeah, and you might want to put my picture back up. I'm done with the iPhone 13. So not yet. This is the first pedal cylinder that we've done. Kits for other cylinders would be fairly similar. And so I'm sure those will come along. But right now we're only up for the Gerdy's A110 36 and the Gerdy's W110 36. Other questions?
Yeah, the question came up, what's the price of this kit?
$375, and then it needs to be supported by a $125 paperwork fee. When the DER approval is involved in something that we provide to you, there's a standard fee. It's usually always $125. That covers me issuing the approval and providing the appropriate instructions that tell you what to do and how to do it, and accomplish it in an approved airworthy fashion. So basically $500 per pedal that you choose to service.
Anything else? More questions? One more. Which models does this cover?
Quite a few 112s and then into the earlier 114s. I don't have that serial range right up in front of me, but you could always just email me and I could check for the eligibility for you. But a fair number of your 112s and some of the early 114s.
Okay, ready to move on to the next topic?
Okay, so now we're going to make a phase change up here and go out to the airplane. Don, if you can go back up one slide there, you'll get to the list of gear topics. There you go. There you go. So you know we have videos up online on I believe they're accessible through .org and also on the Aerodyme YouTube channel. A big long sequence of some videos that were done at the 2017 fly-in at Wright Brothers, I think it was. And so this doesn't try to cover that same stuff. What I thought I would try to do today is just bang away on the main landing gear at about 6 topics or whatever this is, and then we'll bang away at the nose gear a little bit, just to maybe make a few things a bit clearer that may be confusing to owners and mechanics, and to give you guys as owners some places that you could look, you know, on that afternoon when you want to give your airplane some TLC. People see that on my invoices all the time. TLC, Jim, what is, you know, you said, you know, some part of the airplane, TLC, 2 hours. What's that? I said, well, that's the tender loving care that part of your airplane has not gotten in 50 years. And it's a mess, right? And it can vary all over the map, but TLC is a big thing here because some of these airplanes really need to be cleaned up and spiffed up and so forth. So anyway, I'm going to take you under the wing of a 114. So we're going to try to take my cell phone off its mount here, and we'll see if I can make the changeover. I'm going to mute my computer and I'll try to come back on with a cell phone. Okay. Let's see. Okay. Don, do you hear me?
Yes, we got you.
You're live.
Okay. Okay. So we're going to head out to the airplane.
5 years ago, this would have been a $30,000 evolution.
I'm totally impressed. I mean, this is like multi-mode. Go to my iPhone, back camera, wearing a headset.
I would have had to hire a production.
Okay.
Great on this.
My helper, Martine.
Hey, Martine.
That's all you're going to see. That's all you're going to see of Martine. She doesn't want to be in the video. So,
Camera.
all right. So, and out back, let's see. Hang on. See my incredibly busy commander shop here, but here's Tyler working up on the ladder, working on super streaming the tail of this airplane. All right. So, first topic is trunnion forward aft play. So I'm in the main gear well, probably recognizable there. And Don, when I'm down under here, maybe you should take the little picture and make it be the big picture.
Yeah,
It's up there.
Yeah,
Got
your phone is full screen.
Okay. That's not what we see you sending out. We're watching you on our
Little picture.
iPad.
But that's a setting for you. You have to go to the view and change your own view. So you should be able to change your view. Right?
Okay, you guys have the picture under the plane. You have that full
Right.
size?
On our
Okay.
big screen everybody's seeing, it's the full picture from your phone.
Okay, good.
So, and each individual viewer needs to change their own view to be able to expand this
Okay.
your phone picture.
Got it. So
Is
here
anybody
is
else-
the
Anybody else
Here is
online having trouble with that?
I don't think I see anybody in the chat complaining.
Okay.
There's the trunnion. Right up at the top of the trunnion, I'm right here at the forward attachment to the wings, to the canted wing spar. And I'm going right in here. I'm going to see if Martine can come and hold the light up in this area. So I'm going right in here, this gap, right? There's a spacer in there. This is the controlling location for the gear's position forward aft. We're seeing more and more commanders where, for whatever reason, there's a much bigger gap here. And the spacer that's in there is not in contact with the fitting or the head of the trunnion, or maybe both. So it's like the spacer is floating on the pin. There's a big pin that runs through here. This is the controlling gap, because out in the back, out here, this is free slip. There's no control here. This is free slip. So if you are loose up here, then the trunnion can slide forward and aft a fairly significant amount. And when you do hard braking, or you're just taxiing over a bumpy, whatever, transition, runway transitions, taxiway transitions, or whatever, various other times, the trunnion will slide. Some owners report, what is that clunk? And they hear a big one and they wonder, sometimes it's this. So this is set and supposed to be pulled into a cinch by a big castle nut that's located inside the wing. The castle nut is accessed up through this hole right over here, just outboard of the gear door. And let me go around, and I'll make an effort to stick the phone in there. We'll see what happens. See on that screen. Turn it so I can
There you go.
see it.
Hey, got it. Good picture, Jim.
Can you turn it so I can see it? Yeah, I see the big nut in there. Perfect. All right, good. So let me get the light out. So that was number one. Oh, and by the way, we've seen that run loose enough, particularly those of you who might be operating off grass or good but bumpy turf. I mean, our commanders aren't really backwoods airplanes, but we did have one guy over in the UK or something that was off grass. No, he was in Massachusetts, and he was off grass a fair amount, and it was he fessed up. It was fairly bumpy, not hummocked, but just bumpy. And it had cracked his wing spar. This situation was so bad that gear was slamming back and forth, and actually had cracked the whole structure up in here. So that was a major repair, and it probably wouldn't have happened if things had been properly cinched up so that the position was controlled up here. Okay, now I'm going to move on, and we got questions at the end, but moving on to actuator spherical bearing. So we're moving the camera a little bit. Now we're going to point, just trying to get that to work there. I'm going to point right here. And we're going to try, this is the gear actuator, right? Okay. We're going to zoom in here. All right, going right in here. Okay. That bearing right there. Now, Don, can you advance to the next slide?
Okay, hold on a sec. Advance to the next slide. So
Picture, yeah. That PDF is multi-page, so just the next page.
there you go. Okay, it's showing the
That's it.
actuator bearing escape.
There you go. So that's that same bearing. Now, can anybody see? I can't point to it really, but you see that it was a leaker too, unrelated issue. But just below that spot of oil, down there, you can see the bearing. And can you see that the bearing is pushing out?
Yep.
It's like it's pushing away from us in the picture. If you look on the right-hand edge, you can see that bearing is sliding through the casting of the actuator. It's starting to escape to the back, or the casting is starting to escape to the front, whichever way you want to think about it. This is the best picture I had that I could access for today's presentation, but there's a whole series of issues that go on with this bearing. It's not always escape. Sometimes it's just bad damage to the bearing, because there is a problem here in the design. The problem is that the actuator approaches at an angle. I don't know if I can illustrate that, but Hun, can you show me what the iPad sees? So the actuator is not parallel to the wing spar. Martine's trying to show me what you guys are seeing. Yeah,
just about coming over the edge.
yeah, okay, so we can kind of see that. If I could,
There
yeah.
you go.
You can't really see how that, but it is about 12 degrees out of parallel to the wing spar, and that exceeds the rated capacity and the practical capacity of these spherical bearings. That's all they're rated for. And so by this design, Rockwell jammed them up pretty tight. They're at about their maximum swivel freedom when you just install them brand new onto the airplane. And then some other things can go on, like the roll freedom. You notice here, can you see that I'm rolling this actuator easily by hand?
Yes.
That bearing is swiveling. See that? Right? Okay. That's not necessarily true on your airplane. If you go up and grab the actuator on your airplane and try to roll it, it may be very stiff and not want to roll at all. So with a combination of things that can be going on, when the gear retracts and goes up and puts away in the well, there is a lot of force involved at the end of that cycle, at the end of the retraction cycle. If you've ever had the pleasure of watching it, and what you do is, if you want to watch it, you unhook your gear door, usually here at the trunnion, let the door stay down, and then take the gear up, door stays down. Now you can see what's going on. And right at the end of the cycle, you see all of these components, braces, all this stuff, all having a battle for who's on first. Where are you going? Oh, I'm going over here. Wait a minute, I can't go there. I hit some wires. I'm going over here. You know, it's just a mess at the end of the cycle, and everybody gets loaded up pretty good. So the actuator will sort of get shoved to a certain roll, and it can exceed the limits in this area, and therefore the bearings may basically extrude their guts out. So sometimes we see the bearing is still in place. It's not trying to slide out of the end plug, but it's obviously damaged. It's got its metal being squished out of it. So Hun, if you could pass, or Don, if you could go to the next page. Hun, you pass me the tub.
So in your end
That
plug.
guy, yeah, there you go. That's the guy. So on some planes we've had to resort, because they're pretty well messed up. We've had to resort to this guy. I'm holding one up in here now. Now you can see from the picture, or what I'm holding up in my hand, that the lug on this thing is angled. Can you tell?
Yeah. Yep.
Yep.
Right? Okay. So it's angled so that some of the angle requirement is taken up by the design of the end plug. And then some of it is taken up by the swivel ability of the bearing. And so it makes everybody happy. So we're seeing more and more trouble in this area. And a lot of guys call and ask me, can I replace this bearing it's damaged in my current actuator? Can I replace it? That answer is no. That's a very tricky press fit. Don't try it, because you will not get good bearing retention. Once you've taken the one out, you try to put a new one in there, and that could lead you to a place you don't want to go, where you have a higher level failure because the bearing is not actually well retained. So if you got bad trouble with that bearing, it's time for a new end plug to put things in a better place. Okay, next item. If you could tell me what's next on the list, I'll go to it. Door freedom and panel cracks. Okay. Yep. Okay. So let me turn on some extra lighting in here. All right. So we're going to talk about the shoulder bolt for a minute. I'm going to follow the gear brace upward until we get up here to the top of it. So this is where the actuator rod is coming in. It's kind of disappearing behind the brace. This is the brace attaching bolt, but this is the actuator attaching bolt. And that at that area, this what's called the shoulder bolt is used. Martine's going to put me on the shoulder bolt in my hand. Okay. Sorry, I don't have one to put in my hand, but Don, you have a picture of it.
Stand by.
The next page, I think. Keep going. We missed this. We'll come back. There we go.
Go back one.
You had it. Shoulder bolt. Okay, that's a new shoulder bolt, and the factory bolts are sometimes in some trouble because that's a 3/8 inch diameter bolt, but at the end it's only 1/4 inch. See that? And at that end, that's where a lot of stuff's going on. You know, that's really where we're trying to retain the actuator's rod end. A lot of forces involved. So this setup has to be right. The bolt shouldn't be damaged. And what you need to do is take your mirror and look up behind here. I can't really do much for you. Maybe I can get over here a little bit. Up behind there, you might almost be able to see that. There's the nut on that shoulder bolt is back behind here. So you look at it with a mirror, and if it looks distressed, then you want to have a little bit of disassembly done to make sure everything is good up there before it decides to shear off or something. Also, that nut that's on the end of that bolt can be scraping up here, up on the wing spar cap, where the top cap of the spar passes through behind up here, passes through this rib on its way inboard. There can be a big scrape on that because there's very small clearance for the nut end of that bolt to rotate up past through there when the gear's retracted. So if you see a big scrape, you look up in there with a light and mirror, you look around for something that looks scraped up in there. And if you see that, again, some disassembly, some investigation should happen to get rid of that, because obviously if you've got an interference there, and we've only got a 1/4 inch bolt diameter at that point, it's possible to have it hit a few times and compromise it and separate the nut from it, you know, or whatever, because it, you know, 1/4 inch bolts don't like to be loaded in bending, and that's exactly what would be going on up there. Okay. Now, Don, let's go back one picture or one page. And we're going to talk about the walk support stringer. Is that the one we missed, hon? So that's the picture right here. Now I'm going to show you on the, hang on. I don't want a flashing light. All right. So you've got a picture on the screen. You see some damage. I'm showing you on my camera the actual airplane, that same stringer. This airplane has just a tiny little witness spot. I don't know if you can see that by my finger.
Yeah, we got it.
Tiny little spot there, right? Okay. But the airplane in the big projection picture is one sent to me yesterday, because a lot of you in the audience right now are saying, Jim, we all know about this. We've all known about this for 15 years. We've fixed it on all our airplanes. Well, why did I get this picture yesterday? So,
Hey,
so
Jim,
anyway.
can you back out and help me see where that is?
Yeah. Okay. Right. So,
Okay.
well, going under, coming up. So this stringer is here to support the wing walk. We're right underneath the wing walk. That's why he's there. This is caused by the brake bleeder, and excuse me, those of you who are bored with this by now, because you know what's going on. But that is contacted by this right there, brake bleeder screw, right? That comes all the way up and hits here. Now, in the case where this is happening badly, like significantly, like the picture you have on the big display, the danger is that it can break through there over time. And this one's on a pretty good ride, maybe 50% through it. Hard to say from the picture they sent me, but it can break through, and it has on one airplane, and that flight ended in a belly landing. They knew they couldn't get that leg down because the leg was locked up there. The bleeder had caught above the stringer flange. Leg would not come down. It was caught. And so they figured that out. I think they did a flyby, and they were definitely sure they did not have deployment on one of the main gear. So they made the right decision. They retracted the gear, and they did a very expensive but safe belly up landing. So that's why you want to look at this on your airplanes. If it's still happening on your airplane, it needs to be taken care of. Now, your later model, 114B, TC, and many of the older ones will have a relief here. There will be, you'll look up at the stringer and you'll see that somebody has put a relief, like they've cut in about a third of the way, they've come through this area and they've gone back out. That's to create clearance so that that bleeder screw will not actually be able to get caught up there. Okay, that's not really the problem, but it is what the factory did. Is they recognized that the scenario could occur, and that was a way to be much more fail-safe. One of the complicating issues here is that our gear have a lot of freedom, particularly if you think about it. We'll go down here. Look at this leg, this gear leg. It sticks down pretty far, right? And we're talking about an item that's way down here, okay? When that comes way up here, and you consider normal play in bushings, attaching bushings, and so forth, that whole leg assembly is able to move around somewhat, even when it's in the stowed position. And so they make that, when they put that relief in there, they make it pretty long because they don't know exactly where the problem is going to happen. And that can change over time as certain components take some wear. This might land. And that's why in the picture on the big screen, you see two spots where it looks like it's been landing. It looks like a doublet, right? That's because probably for many years it was landing in one particular spot, and then it decided to change a little bit, land in the other place. So now let's see. Let me see my list. We're going to talk bumpers. Those bumpers come up. Is this? Show me that in front of my face. So because this relates to, yeah, I guess maybe I'm jumping around a little bit, but we're going to talk about your bumpers. So Don, you have down a ways, you have a slide of two rubber bumpers.
Yep.
There. Okay. So on the left is the factory bumper, 9102Q. On the right is the Aerodyme bumper. They're a little different, aren't they? Factory's bumper was never going to do the job, and nobody could ever decide whether they should be hard like a rock or whether they should be soft and compliant like a rubber bumper. And depending on who you bought them from and where you bought them and whether they were old stock from Dan or who knows what, or new from the industry, sometimes they were rock hard and sometimes they were very compliant, but they never worked well, no matter which of those they were. So the Aerodyme bumper is a much larger area contact. You see one installed here. So when that comes up and lands on the stop plate up in the wing, it lands with a much more, this is the old imprint of the bumper that this plane had. The new bumper has not left an imprint, but it's landing on much more of this stop surface. And because it is, there's so much more surface area, on most airplanes, if you had the stringer issue from the bleeder screw, you put the new bumper on and it solves it. And the way you would know for sure is retract the gear in the hangar, gear up, tires put away, with a light and a mirror. You can look around over the top of the tire, fiddle-diddle for 5 or 10 minutes. You can get to where you can see whether you have contact at that stringer or not. And of course, what you want to see is lots of clearance. You want to see that the bleeder screw is a solid eighth of an inch, 3/16, quarter inch, whatever, away from being in contact. And then you would just keep your bumper serviced. If you had ever had any trouble with it, you keep it in good condition and go on down the road. Now, while we're here, and by the way, sometimes that issue with the bleeder screw, it might need both solutions. It might need the chamfer, as was done on the late model airplanes, and the new bumper, and then it would be clear enough for comfort. While we're also down here, there is a service bulletin that relates to the orientation of these bolts. So I'm looking at trailing link, caliper attaching bolts, right? You see I have the bolt heads here. This is what I should see here. Bolt heads, not nuts and threads, the heads. The reason for that is that these are lower profile. And when they come up, when this whole thing comes up, the bumper hits the plate. Those heads, some of them may land here. Some may miss, not land on the plate at all. One unfortunate situation involved a commander where the bolts were in the wrong orientation. It's the one that drove the service bulletin. This was a service bulletin issued by Bori. Yeah. So, and it was right on target. So their threads were here. And so it came up and that bolt went right past the edge up here. The threads went right past this edge, right? And they caught, right? Same problem. You're actually locking the gear in that up position because it obviously took some hydraulic power to get that to go past there and get caught. And then there wasn't enough to get it released again. So very important to have these bolts in the right orientation. If they're still wrong on your airplane, get a copy of the service bulletin. I could send you if you can't get it somewhere else or just for your convenience, and turn them around. At the same time, if your bumpers are the old style, replace them with the new Aerodyme bumper. It's easy to do that work at the same time. Okay, next, I think we're going to...
About 15 minutes, Jim.
Okay, good. Door rod. So we're going to go for Don. Don, can you find a picture that's got a yellow plate on the side of... Oh, go back up. Yeah, right there. Okay, main gear door attaching rod. Okay, main gear door attaching rod. Okay, so again, related to a lot of stuff happening at the top end of the cycle as retraction is completing, everybody's pushing and pulling on each other. And the door is trying to be a part of that game. And the door is trying to find a place to stop moving that it's been able to find without cracking itself, right? And on more and more of your airplanes, it is not succeeding. And so what happens is out here, there'll be cracks in the door panel. On most of your airplanes, you may find that the door panel looks like it's been disturbed in this area. It's still just the original exterior sheet metal, but it looks like it's puckered in or something. But on some of them now, you'll begin to see that, okay, it's cracked. So there are a couple of things that are very important here. One of them is this rod many times is all corroded up, and the rod ends are corroded. Everything is stiff and like a rock. And when I take it on a lot of airplanes, I can't move it at all. So what I'm going to try to do here is show you, if I hold my phone still, I can move this one. I don't know if you can see that. I'm moving it. It's free. Its rod ends are free to do a little bit of swiveling, not a lot, but there's a little freedom there. That's critical. We've got to have that. So if you grab your rods and you find that they're just like a rock, that's bad. And we need to get the freedom back. It may be that some of the rod ends, one or both, might actually be damaged because, again, these rod ends are being used at very nearly their swivel limit. So the angle here to, kind of backward rake is making the approach angle for these rod ends be virtually at their bearing swivel limit. One of the things we do to try to help that is, instead of using washers in there, this will be a tricky picture. Can you see up in there? Whoop. Yeah, you see up in there, those are not washers, right? Okay, those are spacers, right? They have a smaller diameter than a washer. So they end up centering the rod attachment as needed, and they provide the cushioning, the spacing, but they don't overlap the race of the bearing and cause things to jam up. So we offer a little kit that has the spacers and stuff that you need when you're trying to do this. So again, if you've got stiff rods, there's no motion. You know, in other words, this is not bad. This is good. they should be able to have some freedom, right? And I've had owners come in and say, "Well, hey, I love it, but look at my door. You can't move it at all, right? It's just like a rock." And I say, "Okay, yeah." And it will crack. That will soon be a crack. So here you have to take off. If you've gotten to the crack, you have to take everything apart, get in the back, stop drill the cracks, and then get on here with this reinforcing plate. Reinforces that whole area, and then on down the road 100 years, whatever you need. Okay, what we not done on the main gear? We're going to change strut. Okay, strut. Yeah, strut. A little bit on strut resealing. We get a fair number of questions. How to deal with resealing the main strut, because many of your struts are beginning to leak, or they're doing the wounded bird thing, or whatever. So one thing is, before anybody tries to pull the guts out of the strut, this is standard Oleo strut 101, common to many airplanes. But before they try to pull the guts out right here, you got to go up in there and clean out that area up inside that bore. It's hard to see there, but up inside there, you got to clean that all out around that casting, around the inside diameter of that casting. Because guess what? When your airplane got painted, what did they do? They loaded that with stripper and with overspray, and they gupped it up, and then there's oil and there's dirt, and some of those are built up very significantly in there. And if you try to drag the strut guts out through there, you either won't succeed or you'll do some damage to things. So that's number one. That's all got to be cleaned out of there before you even make an attempt to release that snap ring and bring the guts down. Okay, the second thing that goes on here, I get this call maybe once a month. It won't come out because they look here and they see that the dog bone, as we call it, dog bone, is tied with a through pin. That's how it's tied to the trailing link. It's a through pin here. Go ahead and try to get that out on your airplane. I won't wait. They are very often corroded in there. And yes, several days of careful TLC, periodic over a several day period, maybe we can get one extracted, but often you just can't. And it's not necessary, because you can service this pretty much in place. But the trouble is, when you're up on the jacks, and we're not on the jacks here, the trailing link drops as far as it can, and the snap ring has been taken out. The guts are coming out of the strut, right? They're pulling out because the trailing link's dropping. Dog bone is pulling out. It's dropping, and you get almost ready to release, but you're lacking about a half an inch. And you're trying to figure, okay, what do I do now? Do I have to take it off at the bottom? No, you don't. A much easier pin to take out is this one at the knee. So you take out the lock bolt. Just see back in here. There's a lock bolt in there somewhere. I don't quite see it on my camera yet, but there's one in there, up in there somewhere. It's also visible outside. This guy's the nut end of it. Okay, so take the lock bolt out, tap this pin out of here. but be ready as you tap it out to put a dowel in its place. So we're just going to tap the pin out and put a wood dowel a bit smaller in its place. I think I usually use like a 1/2-inch wood dowel, about a 6-inch long piece of it. Just stick the dowel through there so that everything stays pretty well where it needs to be. And that's going to give us just enough more drop on the trailing link for the strut guts to finish dropping out. And then they can do some disassembly and then take various parts to the bench and get everything cleaned up, resealed, and back in. This means you don't have to deal with the hose. You don't have to deal with the brake, nothing like that. You just swap this pin for a wood dowel and a little bit smaller diameter, and you'll have the clearance you need. Okay, so I think we're done main gear. You think so? So we're going to go up to the front for a few minutes. And Don, how am I doing on time?
7 minutes
Got
left.
about 12.
Stopped a quarter after, right?
Yeah,
We got 7
7 minutes.
Yep.
Okay, I wanted to save some time for questions, but let me see if I can blast through the rest of this. So now we're on the advance to the page that's labeled nose gear stuff. There you go. Yep, I want the damaged pin. Bring the parts right here. Okay, first we're going to talk about this. So here I am beside the engine, right-hand side, going in here to the pin, the proverbial pin. Now this pin has been replaced with the later style solid wall pin. This is a solid pin, but there's a hole in the end of it. Well, that's because there is a shallow bore in the end of it, which is so that you can get the lock bolt through. You can drill for the lock bolt more easily because there's a relief there. But after that, after about a 1/2 inch, the pin becomes solid all the way through. Instead of this view.
More conduit.
Okay, here's the hollow pin.
What it was.
Okay, so hold that there, hon. So, all right, so solid pin, hollow pin resting just above it. Okay, what's wrong with the hollow pin? Some of you would still have that on board. Now, Don's got that picture up for you. That's what's wrong with the hollow pin. They bend. They can't really take the load. And any sort of accident or damage history in the front end can have advanced this damage very, very significantly. But it will happen on its own over a long period of time. So it's best to have the solid pin in there. All right, let's see. Next, what we have is I think we're going to do the landing gear attach bolt. Nose landing gear actuator attach bolt.
It's a big one.
All right. So go away. Oh, shoot. Okay. All right. So I lost my picture. Okay. I'm back. All right. So your landing gear actuator, when the plane was built, was attached with this bolt. See this little guy over here? This is the one he was attached with. This is the 1/4 inch bolt. This is the one we like to attach it with now. This is the 3/8. It's a 5/16 bolt. The same position actuator attachments on the main gear use 3/8 inch bolts, 3/8 diameter. Can't do that here. Can't do it easily. But we step from a 1/4 to a 5/16. Many of you have already done this, and the reason why is in the picture on the big screen. This sometimes leads to a hellaciously big bang in flight. When it finally decides to leave the building, one owner told me his wife damn near jumped. She was going for the door. So anyway, it was hellacious. So it's best to get ahead of this. Many of you, hundreds of Commander owners, have already done this procedure for these attaching bolts. Strongly recommended. The kit includes the little bushings. You got to change the bushings and pictures about how to do it and so forth. Okay. Oh, and the rod end, the standard rod end used here looked like this. This was the 1/4 inch rod end. And you see that grease fitting coming out of the side of it. Bad idea. that rod end is very weak at that grease fitting location, and many of the rod ends have simply cracked right at that location. So I'll try to put the big guy beside it. So in the kit, that's what you go to. You see that difference? This is the rod end that goes on the plane. So highly recommended. All right, what's next on that list? Up stops. Okay, so we're going to look at the up stops for a minute. If I can find them here. I don't know the light to turn on. All right, so up stop land, gear up stop. Down in here somewhere. Okay. Yeah, so Don, if you move on in your pictures, we're gonna, yeah, that is your old style up stop setup. Both old and new style have a block, which my finger is on right now. And then old style, you have the spring-loaded bumpers. New style, you have the bar of soap, as we call it, up top. But in both cases, these are the guys that are supposed to stop the nose gear from going up any higher. And they need to be kept in proper condition. One very common misunderstanding about the nose gear on a Commander is the feeling that the springs are worn out because you can't get an emergency extension reliably when you test it. So you're thinking, or there's a problem getting a down lock on the nose. You think the springs are worn out. In 24 years, I've never found any springs that were worn out in any substantial enough way to be causing the problem. The root causes are usually different. Sometimes the springs are so rusty you want to replace them anyway. These aren't bad. But the bottom line is, if you put stronger springs on a Commander nose gear, then it will, in fact, deploy emergency deployment with a bit more energy. And it'll help it get down. And it also will retract and stay up with more energy. And it can be staying up because when the gear is in the up position, it mechanically goes over center at about an inch or so away from full up. There's a touch and go point where if the gear is higher, more retracted, it will stay up there. The springs will hold it up. And then if you bring it out some and you start to let it come down, the springs will help it go down. The problem can arise with new, stronger springs, which are sometimes put on, that the gear can't get out for an emergency extension. So we test that if we've ever had to mess in this area at all in ways that might affect emergency deployment. Then you want to make sure that the retracted nose gear with the master off and somebody supporting the tire from underneath and somebody activates the gear dump, right, that it wants to come out. It wants to be pushing down on your hand at about, I say, 5 pounds. So in other words, you're having to do a little bit of work to hold that wheel up there. And the minute you pull your hand away, it comes down. That's what we're looking for. We're looking for it not to be trapped up there and you take your hand away and it stays there, and not to be trying to come out too hard, because if it's pushing and trying to come out too hard, that's going to be more runs of your pump, right? Because that the hard push to always try to escape all the time means that your gear pump is having to do work more often to restore that pressure and pull that back up again into the fully up position. So, Hun, what do you have next? Your actuator. Okay, let's go over to the parts tab here. Don, if you could go to the last picture, I think. Okay, this is just a few minutes on nose gear actuators, old style. For any of you with serial number 112, serial numbers up to 380, you have what we call the old style actuators. So you're using a limit switch based gear system, which used the so-called locking pin and so forth. Commander abandoned that system for very, very good reason. Because, I mean Rockwell, because it was very problematic to adjust and to deal with. So they abandoned it, went on down the road, but they left you with it if you've got a serial, a 380 or below. So we've had to deal with this more and more. And I put the drawing up there just to show you that we're deeply into these things. We're now making virtually all of the parts for them, repairing them under DER approval. And those include, I thought I'd gotten out a bunch of parts, but well, for instance, here, this guy, you know this guy, right? A lot of you have gotten up close and personal with this guy. This is the body. I took that weird thing off the bottom of it. This is the body that sticks out the side of your nose gear actuator. There's a couple of problems when you're trying to adjust that. One is that the hole that the limit switch goes down through in trying to determine whether this is locked or not, the hole isn't big enough for the roller to go in, right? Actually, it's about 5/1000ths bigger than it needs to be. And in real life, 5/1000ths of an inch doesn't do it. So you turn over and look here. Look at that. Can you see that? It's hard to see it. Can you see that hole is square? Yeah. Because the roller has a square profile. Yeah, see that square hole? And it's bigger. So now the roller can actually go down in there and do what it needs to do and then come out again. Okay, that's great. But still, when the roller is in there and the mechanic is trying to tell whether this thing is actually locked or not, right? He can't see because the roller is in the way. So let's turn this around. There's a round hole on that side. That's the view hole. That's for the mechanic to look through when he's trying to determine whether this is adjusted. So these are features that really should have been in the original design by Gertie's, but you know my opinion of Gertie's already. So this really saves airplanes basically by being able to properly adjust the limit switches and get a safe operation. So that's just one part of a whole bunch of parts that we now make for these actuators so we can try and keep you guys flying. Superseding the older airplanes to the newer style system is not a trivial endeavor. It would take me a lot of engineering and it would cost you a lot of dollars to figure out how to supersede your older system to the newer system, pressure based. And so this is what we've had to do, is just come to grips with these Gertie's actuators and be able to do proper repairs and testing. Okay, that's it. If we have any time, then maybe Don would take a question or two. Still there, Don?
Yes, sir.
Yep.
Any questions?
No, I just want to go in.
I know.
Yeah.
We agreed we all need to go
That'll
look at
do
our
it.
airplanes now and
On that bearing, spherical bearing?
What? Ask that again.
I think he's talking about
Yes,
the
sir.
trunnion thrust back and forth. Jim, the target spacing on the trunnion spacer on the front, on the forward side of that.
A pinch, not a spacing, but a pinch. So when you're in there adjusting that big castle nut, you don't get very many choices because it's a big nut, size, I don't know, whatever, size big. And there aren't very many turrets on it. So sometimes one turret where you would put the cotter pin through is clearly still too loose. And the next turret you can't even get to because you can't tighten the nut far enough to get the pin, to get that turret available for the pin. So sometimes we have to put in spacers so that we can bring that to just a pinch is what we're looking for. I think there's something in my gear report that puts a number on it, maybe something like 30 inch-pounds pinch.
8,000? Okay. Oh.
Yeah, it just a pinch. We just don't want freedom. We want a pinch.
Bill, that's the last, if the nose gear make your actuators the last rotating ball, how do you use them?
Oh, Jim, if your main gear actuators don't have that slight freedom of movement,
the
That's-
rotational.
just to rotate it a little to let you know that those bearings aren't loaded up. How do you loosen that up?
Sometimes it's about the hoses and the way the hoses are dressed, because when those hoses go on, they can be pre-biased by just as they're tightening up the B nuts, right? They can sort of take the hose in their hand, rotate it in a certain direction that they'd like it to be biased, and then tighten the B nut. And so the hoses can help because if they are not free, if they're not allowing the freedom, then you can't have the freedom. It's also possible that either the rod end or the bearing end that we look carefully at there are seized up and need lubrication, need to be freed up, and that then you can get the rotation. It's also possible that the clocking angle of the rod end is such that there's no freedom available because there's spherical freedom at the end cap a little bit, and then there's spherical freedom in the rod end, and you'd say, well, the shaft ought to be able to turn freely too, so the rod end clocking shouldn't matter, but it does because the shaft doesn't turn all that freely, rotate inside the seals. So that could be looked at to make sure that the relative clocking from end to end is reasonable. The hoses are not causing something, some unusual loading, and that the condition of both the rod end and the spherical bearing is good. You know, should be able to take it off the airplane and swivel those by hand, right? Just hand freedom of the ball of the spherical bearing and the ball of the rod end. Those should swivel freely. Sometimes if they're all stiff and corroded and dirty, sometimes some TLC will take care of it. You know, lube, wash, flush, swivel, whatever. Sometimes even a little bit of a brass brush on the ball, and not heavy. Sometimes we can get them right back to where they're very reasonable.
The 1-inch sleeve bearings on the inside of that rod that you don't take, the ones that are set up in the strut and
Have a main gear.
bar on that shaft, they're 1-inch sleeve bearings. Where that big nut is, we take up this one on each side. Does he sell that?
Oh, Jim, are you selling the trunnion bearings that go on either side of that pin?
Bushings.
The bushings. It's more of a bearing than a bushing.
They're 1 inch.
About an inch
Yeah,
diameter, large diameter.
The trunnion main bearings
Yes.
to hang the trunnion. Let's see. I think that's one that's about gone from the world. Bob might still have a few of those around. But what we have done, for instance, if I take you back, Don, if you can put my face, do you have my face up on your screen?
Yes.
Okay. I want to show you, I want to go back to this actuator cap we looked at, this guy, right? So this was the guy where we put the angle on the lug for the actuator. Well, let's look at this bearing. This is a new aerospace bearing. It's in there with a snap ring, right? Yep. So what we've done is the same approach, particularly for that forward location on the trunnion hang where we've had to face it a couple of times. We've got a new bearing block and it has a new available aerospace bearing in it, which is snap ringed in. So the whole thing becomes restored to proper health and serviceable going forward. Because I think we have found that being able to get that old type bearing is really can be very difficult at this point in time.
Thank you, sir.
Okay.
Anything else?
Good.
No, I appreciate it.
Okay, Jim, thank you so much. This has been very educational. Thank you.
Thank you all. I hope it didn't offend anyone or run over people. It's hard on Zooming, you know. But thanks all very much, and I'll hopefully see some of you tomorrow.
Yeah, we'll see you tomorrow.
Okay, thanks. Bye.
Appreciate your time, Jim.
Yeah.
All right. Of note on those actuator bolts that he showed you, as a part of your annual, very, very minimum, inspect them each year. Some people, they're not expensive. Just put it on the annual that every year those nose actuator bolts, 1/4 inch ones, get changed. Just replace them. Get done. All right.
His
And-
kit, he sells you,
Yeah, you get a 5/16 bolt, then that it isn't going to be as critical. But if you're still at the 1/4" bolts in there, at the very, very least, inspect them. But and if you can't roll it across the edge of the scale or something, if it has any resistance at all, it's gone. Right? Don't wait for it to break.
especially since it's going out as well.
Yep.
Same person, split open the drop, bolts on.
Yeah, I'll put that picture up here in a minute.
This kit's really good.
Yeah, and the kit's probably the way you should go. But if you don't feel like you're up to doing that right away, then at very, very least,
Hey, how about a 10-minute break? Can we come back in about 10 minutes?
sounds good.
3:37?
3:37. What's that? What's that? Oh, 3:37. Yes, I got it. Took a second.
Yeah.
That was very nice, Jim, to do that.
Yeah.
Good presentation. Yes. There was a lot of good information.
Yes. And since my plane's back in Canada, and I can't just run outside and go look right now. By the time I get home in 3 or 4 days, I won't remember anything.
No,